So in this demo, we'll look at how to implement the query that we just saw as a stored procedure using Code1st migrations and then running it using EFCORS from SQL interpolated function. We'll also look at adding parameters to the procedure so it only returns data for a single customer. We're now inside Visual Studio and we're looking at the migration script which the CarveDog development team has used to create the getOrders stored procedure on the database. As we can see, it's a very straightforward create script that simply creates a stored procedure based on the select query that we saw during the slides. And if we open up this other migration file that we see here, we can see that it creates a stored procedure called getOrders by customer ID, which uses a variant of the query that we just saw, with the modification that this query only returns orders for a specific customer ID. This customer ID must be provided as an input parameter to the stored procedure. And as we can see here, the stored procedure does more than just returning the orders. It also assigns the number of orders that the specified customer has to the customer order count parameter, which we can see here has been specified as an output parameter. If we head over to the Server Explorer, we can see the two stored procedures here. Here we see the getOrders and the getOrders by customer ID procedures. Let's try to execute the getOrders procedure. We can do so here in the query view by using the execute statement like this. And as we can see here, we get back 3 lines of orders. 2 for the customer with ID 4 and 1 for the customer with ID 6. We can also execute the getOrders by customer ID procedure by using the execute statement like this. Notice here that the first thing that we do is to declare the customer order count variable, which we'll use as the output parameter for the call to the stored procedure. The actual call to the stored procedure is done using the execute statement just like before. But this time we provide the customer ID and the customer order count parameter after the reference to the stored procedure. We don't actually have to provide the names of these parameters. We could have just provided the value 4 and the reference to the customer order count variable. But in case of a query with multiple parameters such as this one, it quickly becomes confusing, so we'll keep the names in place. If we execute this statement, we get back the 2 orders that belongs to the customer with ID 4, and we also get a customer order count back that says that the customer has 2 orders. Let's head over to the program class in our console application and try to execute these 2 stored procedures. The first bit of code that we see here executes the getOrders stored procedure and assigns the result to the orders variable. Notice that we run the query on the orders collection on the database context, so the result that we get back will be a collection of order entities. Had we created a more advanced query, we could have provided a special type for returning its result. When we look at user-defined functions, we shall see how this can be done, since the mechanisms are the same in terms of defining the collection in the database context. Also notice here that we used the from SQL interpolated method to execute the query. The advantage of using this method is that it automatically parameterizes all the parameters that we provide in our interpolated string. We could also have used the from SQL raw method, but had we done so, we would have had to explicitly define the DB parameter instances or suffer the risk of SQL injection. The following bits of code here execute the getOrders by customer ID procedure. As we remember, that procedure provides us with an output parameter, which we have to explicitly set up like we see here, where we create the customer order count parameter by first setting its name to be customer order count, the type to be an integer, and the direction to be output. Following this, we execute the stored procedure, passing in first the customer ID input parameter, which we assign with the ID for the first customer in the customers table, and then the customer order count output parameter, where we pass in the SQL parameter instance that we just created. Finally, we read out the value of the output parameter instance, which will be updated once we've executed the stored procedure. Now let's try to run the code. Let's start by moving the debugger past the first bit of code that executes the getOrders stored procedure, and look at the results here in the watch view. As we can see, we get back all 3 orders from the orders table as we would expect. And if we expand the first one, we can see that it belongs to the customer with the ID 4, and it is called this and that. If we advance the debugger a few more steps, we set up the output parameter and then we execute the getOrders by customer ID procedure. We can now take a look here in the watch view, and we can see that we now only get 2 orders back that belong to the customer with ID 4. If we advance the debugger one more step, we read out the value of the output parameter. And we can see here in the watch view that it is 2 as we would expect. So this was a quick introduction to how we can map stored procedures using Code1st migrations. We first looked at a procedure that did not take any parameters, and then we looked at a procedure which both took an input parameter and also returned an output parameter. After having tested the stored procedures on the database, we saw that we could execute them using the from SQL interpolated method on our dataset in the database context. Next up, let's talk about views. Views can be thought of as virtual tables that are based on the result set of a SQL statement. For some scenarios, a view might be used interchangeably with a stored procedure, but there are some key differences. Whereas a stored procedure is a pre-compiled database query, the view is a mechanism that allows us to represent a query, for example a query containing several joins, as a single table. Just like stored procedures, we can use them to encapsulate complex queries. But unlike a stored procedure, a view is an entity that we can use within our queries in the same way that we would otherwise use a table. Views, however, have some limitations in that they cannot contain loops and conditional statements, and they cannot be used to modify the contents of any tables. So in order to implement our view, we need a query, and for this we'll use the query that we see here. What it does is to join information from various tables together in order to present order-related information for all customers in the customers table. As we can see, we fetch data related to orders, and the customers that has made these orders, and the items that the orders are made up of. Such a result set might be relevant to the CarpDog team for querying orders-related data, or it can be used as part of other queries. In the upcoming demo, we'll see how we can create a database view based on this query and then map our EF Core database context to this view. In this demo, we'll take a look at how to map the query that we just saw to a database view. And just like we did for stored procedures, we'll then create an empty code first migration that we can use to publish that view to the database. And after this, we'll create an entity to contain the results returned from the view and then set up the mapping of this entity to the view in the database, which we'll do in the onModel creating method on the database context. We're now back inside Visual Studio, and we're looking at the migration script which has been used to create the customer orders view on the CarpDog database. What we see here is simply a create script which creates a view, the content of which is defined by the query that we just saw in the slides. Let's head over to the Server Explorer and take a look at this view which has already been applied to the database. If we expand the Views tab, we can see that the view has been created, and if we now try to show its contents, we can see that it consists of the 5 rows containing data regarding the 3 orders that are present in the database. We can see here the ID of the order, the name of the order, the customer's ID and full name, and the items that have been purchased along with their pricing information. Before we start interacting with this data, let's take a look at a new entity that has been added to contain the data from the customer orders view. Here we see the customer order entity, which contains fields to match the data that we just saw in our view. Here we have fields for the order, customer and item information that we just saw in the Server Explorer. And as we notice, the entity looks like any other entity that we've been using to map to the tables on the database, except for the fact that this entity has no ID property defined. And now we need to head over to the CarpDog database context and see how we can use this class to map to the view. The first thing that we notice here is that a new DB set has been added called Customer Orders, which contains our new Customer Order class. And as we can see, it's set up in the exact same way that we set up the collections that are used to retrieve data from the tables in our database. If we scroll down to the onModel creating method, we can see that the new Customer Order entity is being configured. Once again, it's very similar to the way that we set up entities that map to tables, except for 2 differences. Since our view has no primary key, we specify that it's keyless. Then finally, we use the toView method to specify that this entity must be mapped to a view, passing in the name of the customer orders view as input to the method. This setup will allow us to query the view in the same way that we would for any of the tables that we've mapped. So now let's head over to the program class in our console application and try to retrieve data from this view. So as we can see, there's not all that much going on here. The first bit of code simply fetches all the contents of the view, and the second one here groups the returned value by order ID in order to calculate the total invoice amount after VAT per order. This last query is included to illustrate the fact that we are able to work with a view just like we would if it were a table. Now let's run this code and see it in action. If we step past the first bit of code and look in the watch view, we can see that we get 5 entries back just like when we queried the view directly on the database. And if we expand the first entry, we find information about the first item in John Doe with ID 4's first order. Once again, just like when we queried the view on the database. Now let's take one step further with the debugger and look at the invoice amount by order variable in the watch view. Here we see that we get 3 entries back corresponding to the 3 orders that are present in the database. We also see that the total invoice amount after VAT has been summed up for each order. And since the CarpDog team has configured EF Core to output debug data regarding the queries that we execute, we can look here in the output window where we can see that the query was entirely executed on the database and no part of it was executed as a client-side in-memory operation. This means that our query has behaved in the same way that we would expect it to if we were querying a table. During the demo that we just saw, we looked at how we can map views, once again using code-first migrations in the same way that we did for stored procedures. We then saw how we can use the toView method to create a mapping between our collection of customer orders on the database context and the view that we had created on the database. After having done so, we were able to access the view in the same way that we would access an ordinary table by using the corresponding collection on the database context. We also saw that we were able to compose further queries on the customer orders dataset. For example, allowing us to execute a group by statement on the result set returned from the view without needing to perform part of the query in memory. And also remember that entities that we map using toView are always read-only, and they're never tracked by the EF-Core change tracker. And now let's take a look at mapping user-defined functions. Just like a stored procedure, a user-defined function accepts parameters, and based on those it executes certain actions, such as performing calculations or retrieving data. There are two types of user-defined functions that we can create in SQL Server: scalar functions and table-valued functions. Whereas the scalar-valued function always returns a single data value, a table-valued function returns a table containing the result set from the query inside the function. Table-valued functions can be further divided into inline and multi-statement functions. In many ways, we can think of inline table-valued functions and scalar functions as parameterized views, and we can think of table-valued functions as tables, as this is how the SQL Server compiler treats them. This also makes sense from a use case point of view, since an inline table-valued function simply returns the result set from a query, just like we did when we created a view based on our select statement, whereas multi-statement table-valued functions allow us a larger degree of freedom in designing the table that we return. The key differences between an inline and a multi-statement table-valued function are that with multi-statement table-valued functions, we explicitly define the table structure that we want to return, whereas an inline table-valued function is defined implicitly by the select statement that it consists of. And then the fact that a multi-statement table-valued function can consist of one or more SQL statements, whereas an inline table-valued function always consists of a single statement. A huge advantage of user-defined functions is that they can be called inside queries. This makes them excellent tools for keeping our queries clean and reusing code, since they enable us to hide complex operations and allow these to be used throughout our queries, just like we would with the C# method. In many ways, user-defined functions are similar to stored procedures, with the added advantage that you can call a function from inside a SQL query, but there are also certain important limitations to be aware of. Unlike stored procedures, user-defined functions must always return a value, and as mentioned, that value can be either a scalar result such as a number or a string, or another simple value, or it can be a data set fetched from tables in the database. And unlike stored procedures that can return several values, user-defined functions can only return one value. Also, unlike stored procedures, user-defined functions cannot be used to update tables or delete or insert rows. Error handling is also limited in user-defined functions. For example, user-defined functions do not support try-catch blocks and other error handling options that are available in stored procedures.